And again, I'll get some of that stuff posted. I find that there's maybe if we have some time later, I might show just one of them that is pretty straightforward for people who have some experience in the languages, but I find that there's a lot of sort of little gotchas that hang people up when they're encountering that for the first time. And that's the, like, where you're having somebody say hello and you pass in the names. That can be sort of, there's just some gotchas for people who are learning coding, getting over the idea of how functions work and how some of this stuff is supposed to be approached. So rough outline for today. Do a quick review. Today we're going to be focusing on objects pretty much all day. That's really, I'd say, a lot of the focus, or at least a lot of the stuff that we work with through the rest of this class is going to be object focused, sort of object oriented. And that's, I'd say, at least two major reasons. One is it's probably the dominant programming paradigm right now. And so being familiar with it is really important, because if you're not familiar with how to work with objects and operate on them, then you're going to be at a major disadvantage. And also, it's probably the concept that is the most, I don't know, foreign, different from what you'd be used to. So it's a challenge to learn how objects work in programming in general, because they're a pretty powerful concept, but there's a lot to go with them. And it's also a challenge even for people who are familiar with other programming languages because of how they operate differently in JavaScript. And so especially as we start getting into this stuff for the homework, start getting into working with this stuff, speak up. Let me know if you need clarification. I do have a survey, I think, that I should be sending out after class. It's just sort of a quick touch point of how you thought it went. And I'm going to be trying to do that more often so that we can gauge how class is going, if we need to move faster or slower, and figure out how to really help people work through all of it. But we'll just start with a quick review of creating objects using the object literal syntax. Does anybody remember, before I show it, how to create an object using object literal syntax in JavaScript? Yeah, it's pretty much it. Objects can be created just by starting the object with an open curly brace, creating a set of key value pairs separated by a colon for each key and value, and then ending it with a closing curly brace. So that's just what's known as object literal syntax. So here's an example of one with 3 properties on it. We're creating a hero object. It's got a name, a real name, and then a list of powers as an array. Any questions about the idea of object literal syntax, how to create an object that way? You'll see, as I said, it's just whatever your variable name is equals in your curly brace and your closing curly brace, and then inside of there, key colon value, key colon value, and key colon value. Let me make sure I'm streaming. Okay, looks like I am. Inside of an object, or when you're working with objects, properties can be accessed using dot notation. So if I take this bit of code here and we put it into this REPL loop, so we've got a hero defined, hero. We can access any properties off of him using dot notation. So dot name. And since this is a REPL loop, if we go back, remember, it prints out the result of evaluating that line. But you know, if you were running this inside of a program, a file, you would need to do something like that to print it out. So you can do it with any of the properties, hero dot real name, and then hero dot powers, and I get back the array. So that's just probably the most common way to access any property on an object is using that dot notation. And you can use that same dot notation to add or change properties on an object as well. So here we can go back and we've got our hero of Barry Allen, and he's got a city that he's in as well. So we're going to add a city to it, and he lives in Central City, I believe. If we see now, we've just added another property to our object, just using that dot notation. You know, let's say I added it wrong. I had a typo there. It's like, oh, that's not the right city for him. You can just change it. You can also change the value or modify the value of the existing properties using that same dot notation. So a slightly more complex example of that is if we show our hero again, he's got a powers, and this is an array of stuff, and we only have one thing listed in there. So I'm going to do a slightly more complex line here, where if I do heroes.powers, that will give me access to that array. That returns that array. And if I want to add something to an array, I can just use the push syntax or push method of an array. And let's say now he also has access to the speed force. So now if we look at our hero, we see that his array of powers includes 2 items instead of just 1. And that's all just using that dot notation. In this case, it's using dot notation to access the variable on it, which is an array, and then using the method that exists on an array, the push method, to add something else to it on that same object. Does that make sense? That one's it looks really simple. You see this one little line thing, but there's a lot going on there because there's a lot of different behavior happening, right? As I was saying, it's the first dot here is accessing it, and the second one says, oh, now that I have an array has a push method, so I can do something to it. And that's sort of combining those two different, or some of the different tools that you have access to on an object. So that's just working with dot notation. Any questions on the concept, those concepts before we start diving into some of the other stuff, the new stuff for today? All right. So today we're going to be focused more, again, like I said, almost for the rest of the class, we're going to be focused on objects and working with objects in one way or another. So there's a whole domain of programming known as object-oriented programming. And the concept of it is it's a way to write program using objects. Oh, okay, that sounds pretty obvious. You see object-oriented programming, you feel like it's all complex. Really all it means is you're writing programs using objects and objects interacting with each other. When you're using object-oriented programming, you write, create, and modify objects, and the objects are really the core thing of your program. That's what interacts in your program, as opposed to, so far we've written what would be just sort of imperative or procedural programs that go from top to bottom. Instead, in object-oriented programming, it's these different objects interacting with each other. So it's really going to change the way that the program's written and organized when you're writing object-oriented programming. It'll be different than the function-based or procedural code that we've written so far. But there's one major tool that we're missing in order to accomplish that. And that's that to really turn objects into the primary item we're using in our code, we're going to need to be able to associate actions or behaviors with our objects, not just state like we were doing on this hero object just a moment ago. And the way that we do that is actions on an object are called methods. Method is just another name for a function that is part of an object. There's nothing extra fancy about that. So let's go ahead and use this to add the ability to say hi from our hero before. So I'm going to steal all this code and throw it up into the JavaScript interpreter in just a moment. But this is the only new thing in here is we've added a new property, a method, to our hero object here. And we see it's a key, just like before with greeting. But the value, instead of being, you know, a string, an array, something else, it's a function. So the value of this greeting is a function, and that's just going to log out, hello, I'm the Flash. And we can access that using that same dot notation. But in order to invoke a function, you have to use parentheses. So we use those parentheses. So if we go back over here, I'll exit out of this and start a new one just so that we're fresh, don't have any history. I missed something. I missed a comma in here. You have to have a comma between each property when you're declaring them using object literal syntax. And you can see it's complaining at me because I missed the comma that should be right here. And that's what caused all of this to break just now. So I'm just going to write it out instead. Hopefully get it correct when I do it here. Oh, I don't want that to be his name. Not everyone can know that. Give him a real name, give him some powers. We'll just focus on super speed. And then let's add this greeting property. It's just a function declared like all our other functions. The only difference here is we wrote function without a name over here. We could even put a name here. We could say greeting again. It doesn't matter. If you write it without that extra name, it's actually what's known as an anonymous function. Hence, it has no name. Now, mind you, it's assigned to the property greeting here, but the function itself doesn't have a name if we leave it off. And that's usually pretty common when you're writing functions on object literals, is you'll use them as anonymous functions, but you can give them a name as well. That's a perfectly valid pattern. So let's have him say, I'm the Flash, and end our whole object, and we should have a hero object. And now you're going to see some cool stuff, and this is because of the way that this read eval print loop in Node shows you a summary of what this is. Oh, this is a function. This greeting thing is a function, right? And you could even see hero.greeting, it's a function. So if I do that, I have access to the function itself. I have a reference to the function, but I haven't called the function. I haven't used it. And the way I use that function is by putting those parentheses afterwards, which says, call this function, run the code inside of it, and we get, hello, I'm the Flash. And that's part of our hero object that we have here. Does that make sense so far? Any questions on just adding a method to an object? Did anybody see where this might be, where we've got some sort of hard-coded stuff that might be a challenge here if we're trying to leverage this a little more? So what if I want to change the name of my hero? What if he's like, oh, I can't go by the Flash anymore. I want to have a different name. That's cool. We'll change his name. Hero.name equals, I don't know, the yellow Flash. All right, so now he's got a different name, but his greeting's wrong. Okay, we've got a little bit of a problem here going on. And that's not that that greeting method was wrong in any way. It's just that it's not very flexible, right? It was hard-coded. It's specific to this exact hero, this exact name. And if I want to make it more dynamic, more flexible, we're going to have to change our code a little bit. So does anyone have any ideas about how we might be able to make this a little more flexible? What? Plus name? Interesting. Have you programmed in a different programming language before? Okay. That's really interesting. So let's, I'm gonna fix this. I want to be able to, let me see here. what am I going to do? You know what? I'm going to pull my terminal down a little bit and put this stuff up into this Scratch file instead so that I can change it and run the whole thing. Fix my typo here. So you said do something like plus name. All right, let's see what happens. I like the thought. So if I try and run it, it yells at me. It says name is not defined. It's a nice try though. I like it. And we're going to come back to that in just a moment. Yes? Yeah, we're going to get there in just a second too. So one way we could fix this is a little interesting. We actually give this guy a variable, right? He gets put into hero here. We can refer to that variable inside of this. So we could say, hello, I'm hero.name. And then it will work. And then if we change his name, for example, it will reference the correct value off of that, right? Because it's that same dot notation. We're just doing it inside of our method in our object. Does that make sense? That's one way we can do that. Now, does anybody see a problem with this? This one's going to be more subtle. Anyone see how we could cause a problem with it? I'm going to write a bit of code here that might cause a problem with this. I'm going to take all this and go back to doing it inside of the read-eval print loop, just for the sake of what I'm trying to show here. So now I have my hero, and I can do hero.greeting, and it works just fine. And if I change my name, it should also work. Let's see here. Awesome, we're working, right? Now what I'm going to do is I'm going to put this in another location. I'm going to create another variable. Heck, we'll just give it a hard-coded name. The flash equals hero. So what I'm doing is saying this flash now points to the same variable as hero, which isn't going to break anything. Everything works. But then what I'm going to do is change what hero points to, and let me just make it like a string. I don't know. So it's not even an object anymore. So if I look at hero, I get this. But here in the flash variable, I still have a reference to my original object. And there's a lot of complex stuff going on here. You don't have to understand everything that's happening here. But now if I try and do, it won't be hero because I no longer have a reference in hero. Hero.greeting is going to fail because there's no greeting method on hero anymore because it's just a string. But I do have the flash, and I can do the flash.greeting. And that doesn't give us what we want. And that's because it's trying to read the name property off of the global hero variable, which no longer has a name property. It's now undefined, right? And that's, again, don't worry about all of the details of how I set that scenario up. But that's something that could happen is the variable changes. And so if you're referring to the global name for that variable, that could cause you a problem if that's the way that you write something out, right?
So can we avoid this problem if we leave the function outside of the variable?
Outside of you mean if we don't put it on the object? Potentially. So if you did something, yes, that's one way. And in fact, now I'm not going to say that that's common in like object-oriented programming, but there's a whole model of programming where your objects just have more or less properties, and then you pass those into functions which can operate on them. So for example, if we built this a little differently, if we create a function and we call it greeting, and it's going to take a hero in, and that function is just going to console.log like hero.name. Now we've got this thing outside of our object, and we can pass in the flash and it'll print out the flash, or we could, have it say more than just that, right? And so that is definitely one way to compose stuff. I'm not discounting that. In fact, if you were to ask me, I'm a big fan of this model. This is sort of my preferred approach, and I push very heavily to not do a lot of object methods on things if possible. I'm a big fan of function composition. So yeah, that's one of my preferred solutions, but it's definitely not really the idea behind object-oriented programming. That's more functional programming and using your objects in a little bit of a different way. And so nothing wrong with it whatsoever, but not the same concept as what you're trying to capture usually with an object-oriented type model. So the way to fix this is this, and this word can change in different programming languages. I heard somebody say self. I think that's what Ruby uses. I don't know if self this, I don't know if there's anything else used in a different language besides self or this. I think those are the two most common ones. But let's talk about that, right? Like in real life, we don't usually refer to things by their formal name in a conversation. If you're reading a book, every time someone's mentioned, it doesn't use their full name. It's not like Jared said this, Jared said this, Jared said this. We're usually using what instead of names, or he. Yeah, we're using some sort of pronoun, right? Some sort of shorthand that lets you know, oh, this is referring to this object in a specific context. It's helping you know what you're referring to in that context, and that lets it be flexible, right? Because that way you don't have to change every reference to something. Again, it's almost the same thing. In a book, if you change somebody's name when you're writing, it's really nice that you wouldn't have to go through and change every sentence to say Jared, Jared, Jared. Oh no, I changed my character's name. Oh man. I only have it in a few places, and then I say T in other places, right? Or I'm referring to an object, right? Like, oh yeah, the bottle of tea or the bottle of water, and then you can say, it just sat there. It's nice that it instead of something else, right? So objects in code also use a pronoun to refer to themselves. It's the same model, and in JavaScript, it just happens to be this. So going back to what you were saying, the name, exactly, you can do that. The only key is you have to tell it what object you're referring to, and you have to use this. Now, I will say in, say, Java, for example, so just stepping out of JavaScript, it's horrible that I'm saying Java because it gets confused with JavaScript. So let me use a different one. In C#, if the property, if it's able to understand the context and know what that property is, you don't always have to tell it this, because it can figure out, oh, the only property that could have that name belongs to me, so I can assume this. In JavaScript, you always have to be explicit about it. So here's a pared down version of our little bit of hero code. And let me just steal the greeting bit. That's all I'll change. And you notice really the only thing that changed here was, hello, I'm this.name is how we refer to him now. So now if I were to take all of this and put it into, I'm going to exit out of this, open another one, open node again, paste my code in. I can do hero.greeting. I get yellow flash because that's what I had up there. And then I can change my name. Do a greeting again. Oops, that's because it is trying to reference the other stuff. Sorry. Hero.greeting. It should be correct. And if we went through that whole dance that we did before, the flash equals our current hero, and we change hero to be like Superman. we still have the flash here, and we can still do the flash.greeting, and it works correctly. And that's because it's not referring to anything outside of it in this global scope. It's referring to itself. It's got this self-contained context of this is what I'm referring to. Does that make sense so far? So that's one of the most powerful, like that's really the big focus today, is working with this concept of this, working with methods and this. That allows objects to be these self-contained, very powerful entities where you can print out a whole bunch of information that you're hiding from something else. So we were talking about some of the building blocks of code before, how you build something larger, right? You use abstraction and you use encapsulation. Abstraction, this is helping to hide the details of something and only exposing the bits that you need to expose. And then you can compose something larger out of these different objects. Now, if we change the name, it still works correctly. If we change the variable name that we used to point at the object, it also still works. All right, so let's have another example. To try and emphasize this, a little bit more complex, putting more of these building blocks that we've been learning together into one bit of code. So in this case, we're going to create an ice cream cone, and it's going to have a type. It's a waffle cone, and we're declaring some of this right here in our object literal. And then it's going to have an array of scoops in our ice cream cone, and then a get description method that's going to return a description of what you ordered. And that sort of runs off the side here. Don't worry about that. And if we run all of this, if we took this and ran it real fast, I can put it up into my scratch pad. So I'll just run it from up here. Scroll down a little bit so we can see it all too. See that at first, the first time it logs something, we get description, and it tells us you ordered a waffle, a waffle of cone, nice. I don't think it needs to say of. Let's get rid of that. Make it a little more proper English. You ordered a waffle cone with scoops of, and there's nothing in there. And then going back to being able to reference stuff, we've got our cone object, which has a scoops property, which is an array, and we're just pushing some scoops of ice cream in there. I like that. It's sort of how ice cream gets in your waffle cone anyways. You just sort of push it in there, right? And then we print it out, and we get this nice bit that says you order a waffle cone with scoops of vanilla and chocolate. Does that make sense? Any questions about this? Come on, somebody should have a question about this. What? What? What are you talking about? Yes, I did. Wait a minute. What was that? How did I get that string back, right? What's going on here? What's this $sign bit? And why am I not doing like a plus and then my this dot type and all this other stuff? Yeah, let's introduce another little bit of syntactic sugar. We'll just sidetrack and show you this because it's a really nice way to simplify some of this. And that's what's known as a template literal. So this is a sidetrack. This isn't directly related to objects. This has nothing to do with it. It's just showing you another nice little newer JavaScript syntax. Older versions of JavaScript, so like older versions of Internet Explorer, for example, wouldn't be able to use this syntax directly. So that's why I don't teach it at the very beginning. I'm teaching you the version of JavaScript that's the most compatible with everything. But this is a nice bit of new JavaScript syntax that will run in any modern version of, say, Node, which is what you're using, or modern browsers, and can make life a little easier. And that's, we don't have to concatenate using the plus operator all the time. Instead, a template literal is just delimited using the backtick character. And this is a common question. What's the backtick character? Where do I get that? On your keyboard, it's probably in the upper left, right over there, because you probably have never used that key. It does a tilde and backtick. Probably one of the least used keys on your keyboard, except for in programming. And then variables inside of a template literal can be referenced by escaping them by wrapping them in this $ and curly braces syntax. So a very, very simple example here, about as basic as you can get, is if I have a variable of name, I can print out my name is $ curly brace name and curly brace. So I don't know, do people think that reads easier than the concatenation model? Yeah, you think it reads harder? It's a little confusing to have the variables right there in line that way. So if you like it, you can feel free to use that syntax for creating strings going forward when you're needing to put some of those variables in line.
This is also known as string interpolation.
It does string interpolation, yes. So that's what it does under the covers. It's called the template literal syntax. So that's why I use that term, because if you're going to Google like JavaScript template literal, that's what you want to be searching to find the definitions, the explanation of it. And there's a lot of complexity behind it. Like it can be used, this is sort of the page explaining it, or probably one of the more dominant ones. It can do a lot of complex things. You don't necessarily need to understand everything about it or like dig down into all the details. Might be a useful thing to do though. I really do encourage you, I don't think I've emphasized this enough in class, is whenever you have questions about stuff, look up documentation on it and try and read some of it, even if you don't understand it all right now. And a really good reference, I would recommend Mozilla's site. So it's known as MDN, the Mozilla Developer Network. I think it's a much more trustworthy site than some of the top results you sometimes get on Google. So I'd encourage you, this is a really good one. They'll have, you can even see over here, here's tutorials for JavaScript. So they break stuff down in a lot of different ways as well. But this will really dive down into it. We won't get into all the details of it because it can do a whole bunch of stuff beyond just this simple string interpolation with the template literals. But that's what we'll be using it for, is string interpolation. So it's just a nice, easy way to put your variable name right there. And for example, and I'll get to it, maybe we'll talk about it at the end of class, but I know when you're doing that, say hello or whatever, and you pass in a first name and last name, a common challenge a lot of people have when they're working on that is getting the spaces correct, because that code, that the tests require that the spaces are the way that you would expect the spaces to be. And I think a lot of people, now let's just work through it right now. In fact, let's take a moment and work through that. I don't remember the exact way I defined it, so we may play with it a little bit here. But it took a first name and a last name. And the goal is it should return, you know, something like, hello, John Doe. Let me put quotes around this. Right. So I'm going to work through this, as I know it's sort of and I'll show you some of the common things that people do when they're first encountering this assignment. And I think this has to do probably with not teaching functions as the very first thing a little bit, and some of it just has to do with not quite picking up all the different bits of how you do a function. So a lot of times what I'll see is sort of the first version of what people will do to solve this is they'll do console.log hello John Doe, right? And if we run this, I mean, oh, I'm not calling it. Yes, and then they'll call it, right? They'll say hello. If we run that, you'll see hello John Doe printed out, but that's not going to pass the tests that we have. And anybody do this? Was this anyone's first attempt? I know I've seen this just about every class. Somebody's first attempt at solving this is something along this line, right? And the key there is carefully reading what it says, which is this, if you remember right, I said this is going to be just a side effect in your function. And this says you need to return something instead. So if we were to look at what gets returned from this, as we've done before, return value, and log that, along with what we printed, we'll see that undefined is what we returned, because we didn't define any specific return value. Okay. So I get it. I can fix this. I need to just, this is easy. I'll just return hello, John Doe, and then I'm going to work. Right? Oh, good. I get it as return value. Except then in my tests that I had written for this, I'm not checking for just John Doe. I gave that as an example, not the only one. And so I'm going to write a test that calls it and says, I don't know, Steve Rogers, and I expect it to tell me hello, Steve Rogers as the output. Oh, and it doesn't. So that's why I'll bet some people got caught up with that, right? Oh, I hard-coded returning John Doe. Shoot, I need to actually, it needs to be flexible. Okay. I can fix this. We got this. This is easy. Hello. Now I have to use my variable names. And actually one that I think some people do sometimes too is they'll declare the variables like in here as well, like first name. I'll be like, I fixed it. You know, I'm going to use the variable name or something. And I'll just run this way or whatever, but that won't work because you need to be able to use whatever gets passed in, not inside of it directly. So then the next thing that people commonly do when they're solving this one, wow, I cannot type, is they'll do something, you know, okay, now I've got it. Oh shoot, it didn't put the spaces in that I need. Oh, okay, I can fix that too. I will just put the spaces in my stuff that gets passed in here, right? Ah, problem solved. It looks right when I print it out. Anyone know what the issue is with that version of it?
Yeah, somebody's going to look at their name, they're not going to insert spaces for it.
You can't rely on the person calling it to put those spaces in. You need to put the spaces in, right? And so when I call it in my test, I don't put the spaces in. Your code failed because it doesn't have the spaces that are needed. Anybody get caught up with that one? Yeah? That's another common one. I've seen it probably every time we've done this. So the key there is, oh wait, I just need to assume that this is whatever that first name is. I can't, in other words, I have no control over the parameters that get passed in. So to solve the spacing thing, I can't change what gets passed in because it needs to support different stuff. So I solve that by instead putting my spaces up in the code itself. You have to solve the problem inside of the function, not outside of the function. That's the key to getting that sort of functional programming right, is I can't solve it by changing what gets passed in. I need to solve it by changing my function itself so that it works. So that's a little gimme for anyone who didn't get that one solved yet on the homework. Let's sort of walk through a lot of the common gotchas that people encounter when they're doing that. I hope it helps you sort of see where that can occur. I don't quite know if maybe I'm missing something in the way I present some of that with some of the stuff that happens, or if it's just a challenge to pick up the way that functions work and the way that you need to operate on them. And I know that for me, I've been doing this for quite a while, so it can be a real challenge to know that those are going to be gotchas, because I'm already thinking, oh, this is the way that you would do it. And then when I see people coding, it's like, oh, okay, I don't know what I need to do to present it a little differently to help out with that. So if there was anything also on that one that you think could be clearer to make it easier to pick up and skip over some of those gotchas, let me know about that too. But we could also, now that we know template literals, we can make this whole one maybe a little easier. I don't know. It depends on how you want to think about stuff, because some people may think this is easier to read and some people may not. I could rewrite this guy using a template literal now. And it might be a little easier to see how to put the spaces in, for example, if that's part of what tripped you up, is I just put them in right there and then I put my name and stuff here. I don't know, but it's a useful tool to have. All right, any questions, template literals? Something that you don't have to use, that's purely up to you if you want to use that. So we've been flying through this. I thought that this might take a little longer. We may get a chance to just start touching on some more advanced concepts, but let's talk about object uniqueness. So just because two objects have the same values doesn't mean that they are equal to each other. This is an important aspect of objects versus strings or primitives, right? We're already familiar with the concept of, if I have var num equals 42 and var num2 equals 42, if I were to compare them to each other, they're equal to each other. And even if I did a triple equals, pop quiz, what's the difference between double and triple equals?
Triple compares the property, like this is a string or a number. The triple compares the exact value.
Yeah, double equals does what's type coercion. So it'll convert one type to another if it can. Triple equals will never do that. So if they're different types, a string versus a number, they'll never be equal with triple equals. Double equals, they will be. But that's true, right? And that's the same case for strings, right? If I have name equals, I don't know, Superman, and then I have other name equals Superman, and I compare them, they're the same. What about this code? What do you think is going to get printed out when we run this bit of code, where I'm creating two different objects, two different cars?
Yeah, I think it's going to be, like, it is true. It's going to work. Because it's not comparing the exact values.
All right. See what happens here? I'll put all this in. We'll run this bit of code. Oh, I must have screwed up somewhere. Oh, can't take my whole slide. None of that's valid code. Let's try it. They are different cars. Yeah, that goes back to what I was saying. So back here, just because two objects have the same values doesn't mean that they're equal to each other.
So you can't compare objects.
You can't, object comparison doesn't work the same way. Imagine, I chose cars because I think it's nice and easy, right? I chose Prius also because my wife has a blue Prius and I see bajillions of blue Priuses on the road. Just because I see another blue Prius doesn't mean that it's her blue Prius, right? And so when you're creating an object, especially using object literal syntax like this, each one of these actually points to a different object. So I'm going to take this code. Let's go ahead and throw this into this REPL tool that we've used before, or this nice little Python tutor bit. Make it a little larger here. I'm going to visualize the execution. So if we look at the start of this, we've created two different undefined variables. And after I've run this first bit, I have car1 pointing to an object over here that has type Prius, manufacturer Toyota. And when I run the next bit, what I did is I created another object. It just so happens to have the same values. And what it's actually comparing when it compares two objects is not, it doesn't look at all these values. It looks at, do these point at the same place in memory? That's what it's looking at. So it does that comparison. It says, oh, those don't point at the same place. Now we could do that a little differently. If what I did here was instead of saying car2 equals and created a new object, I said car1. What's going to happen when this runs is I create this car object, and then I just created something else that points to the same place in memory, because I just assigned that same pointer over to it. And now, sure enough, they're the same car. So it's never going to directly compare all of the values in an object. If you want to do that, you're going to have to use a different tool. Like there's libraries to do it. There is a way to iterate over everything on an object. We won't really get into that today, but you can step over them and see if they have the same values. That'll probably be a programming assignment as well at some points to say, like, do these objects have the same set of values? But they have to, the key is it's what it points at, right? So also another example here is if we go back to what we had before. And if I change one of these values because they're pointing at two different things, and I said, oh, this type is now a, I don't know what else, actually a Corolla or something. I need to put another line here just so that I have somewhere to step to when this runs. Well, if we run this, we'll see that since they point to two different things, when I changed the type, I didn't change it on both of them, right? I changed it only on this one object. But again, if we go back here and we change this code so that car2 points to the same thing as car1, now if I change my type of vehicle, it changes for both of them because it's changing the value that they point at, and they both point to the same thing. Saw a puzzle expression? Some confusion over that? Oh. Let me change this code even so it's a little more explicit about what's happening here, just so that it shows it a little better, right? I'll print out both of these. There we go. So what's happening here? This is a little bit of a tricky concept, I guess, but it's important to understand over time because you need to understand how a programming language refers to different things. And this will vary by programming language. This is the way that objects work in JavaScript. Other programming languages may be a little different, although this pattern is pretty common. And the idea is, again, when you create an object, what's actually stored in that object's variable name, if you're holding on to it, is a pointer to the object. It's not the whole object. So this points over here. And so if right now I were to have a line that said, you know, console.log car1.type, what it would do is it would go car1, okay, I know what this is, follow that pointer over here, and now read the type and print that out. So now when I run this next line, all I did was say car2 also points at the same car. It's just another way to refer to the same car. And so if I change this, the type of it, then when it runs these lines, it's following that what it points at that point in time and going to print that out. So I know that that's probably going to take a little while to step through, but I encourage you to try out stuff like this again, because it'll help you hopefully capture that concept and what's going on in the code. And now if we went back, like for example, yes?
Is this a common practice in JavaScript where you create a copy of a variable, change a property on a copy to change of? Seems strange to me.
I would say it's a good question. Is it common? Directly, that explicitly, not necessarily. Maybe not that explicitly, but it is common in a way that is more implicit that people may not realize is happening.
So it's more like something
Well, no, it happens, but it happens sort of more implicitly. So let me give an example of how this happens. And I can write it out here, and it'll be it's adding a little bit more. If people remember a couple classes ago, we talked about the idea of passing by value versus passing by reference and how that works differently, and how every type except for objects in JavaScript get passed by value, but objects get passed by reference when you pass them into something or pass them around, right? So that's probably the most common way that this happens. Is, let's say I create a function. And I'm going to call it change type. Let me change what I call this. I'm going to call this model, because it's just a little more clear when I create my function name. See, look, I learned I had a bad variable name. I'm going to call this change model. And this is going to take in a vehicle. What this is going to do is do like vehicle.model equals, it's going to take in a vehicle and a model, like a new model. So all this is going to do, this is a little weird, but all it's going to do is change the model on this vehicle. And then, oh, well, I want to make sure that if I change this, I return it. And this is a little redundant, you'll see, but okay. So I've done this. I've got my car. I'm going to print out the model of it. And then I'm going to call change model because, or I'm going to call it change model because it's more explicit about what it's doing. Because you could do this by accident as well, which is a very common thing to have happen. But since an object gets passed by reference and not by value, this probably won't have the obvious expected behavior. So I'll say car, and then I'll say this is a Corolla. I'm going to put this in the car too, because it's returning a vehicle here. And I'm going to log car1.model and car2.model. And I'll even log car1. Are these the same? Oh yeah, thank you. So let's see what we have. Probably have a typo, but okay, so I'm creating a car. So now I have a car, it's a Prius and a Toyota, and I'm gonna print out the type of car that it is up here, or the model. Now I'm going to go into change model, but you'll notice because an object is passed by reference and not value, that the vehicle inside of this function points to the same place, the same object as the one outside. So when I changed the model, I changed it on that object. I didn't create a copy of that object. And when I return, I actually just return another pointer to that same object. And now car and car, oops, this isn't gonna work. That line's gonna break, but that's okay. Because I say car 1, these lines will break. So let me fix those. Some typos. Where's my typo now? Oh, was it? Okay. So let me step through that again a little bit. And now you see the original car now says it's a Corolla, the pointer from the original thing, as well as the new one. And they point at the same object. So that's true. Because it's checking, do these two things point at the same thing? So that's probably, your question of, is it common to create a copy of it and change a value and have it change on both? That's probably not a very common pattern. It is much more common to do this. And sometimes you do this intentionally, but this also happens a lot of times by accident where you're not thinking that, oh, I was modifying my original object. And now I've changed some state outside of what I thought I was changing. So sometimes this is intentional, sometimes it's accidental. It's also, and this is getting deeper than we'll click right away, but another time where that's very common to have that happen is if you have an object inside of an object, like one of the properties on your object is another object, and maybe in some of your code, you store a reference just to that instead of to your whole object, and you change something on it, that's still going to change like what the original one referred to, and that gets tricky, and that can happen as well. So it's something that you definitely need to be aware is happening, but you're not going to usually write it out that explicitly. It's a good question. Any other questions on any of that?
So is there a way to make a second object and just say copy all the properties, make it?
Yeah, there's a lot of, traditionally there wasn't a really nice way to do that. In JavaScript, there are now, using some of the newer syntax, there's several different ways to do it. I'm trying to remember the exact syntax. Is it assign? Let me look at me. I think it's assign is one of the most common versions of the syntax here. So here's one of the common ways to sort of do that. Again, it's not, I wouldn't worry too much about it right away, but one of the common ways to do that is use this object.assign, and that's a method on the object. This gets into stuff that you guys haven't dug into, but the object or prototype of objects. So objects get created off of an object that is like the base of all of them. And it has some stuff on it as well. So if I get rid of all this, we're going to create a car, and it's got a model, and we can create a car 2, and we can do object.assign, and this is where you need this is why I said you've got to at some point get comfortable learning how to read the documentation, because you're going to need to go and look up, how do I'm familiar with this function, how do I use it? And this is, sort of complex, but it tells you what's going to happen. So the way I use object.assign is, it says the object.assign method is used to copy the values of all enumerable owned properties from one or more source objects to a target object. Okay, a lot of verbose words, don't worry about all the details. So the target object is the first argument that I pass in. And then the sources are anything after that. So it can be any number of other arguments, and what it returns is the target object. So a little bit of creative thinking leads you to say, oh, I want a new object that has everything, and I don't have that object yet. So my target object is just an empty object, which is going to be a new object. And then I want all the properties of my original car. Let me throw some extra stuff in here to help show what's going on, right? Just to help emphasize it. Console.log car2.model. I can change it now. car2.model equals. What else do they make? I don't know what it makes. A RAV4. Is that their vehicle? I don't know. Probably get mad at me if they don't. So what this should show, if I don't have any typos, is we create our car object. We go ahead and print out what it is. Car2 points to a new object that copied all of the properties from our original car. And so now when we change stuff, it changes just on that one and not on both of them. So that's the more verbose way. There is another way to do it that's much newer syntax. I don't know if it's going to be supported in this. I'll try it real fast, but there's a good chance it won't be. And that's known as like this object spread. And basically what I do is I declare another object literal. And then I do this ... and say, I'm just taking everything off of this other car and mixing it into this new object. I want to take all those properties and point at it. This may not work. Yeah, it doesn't know that syntax. And that's because, again, that's me trying to stick with more traditional syntax, stuff that's going to be compatible in more places. So, and then before object.assign, which I still think is even new, let me double check. That, yeah, Internet Explorer doesn't support it. So that's even part of the 6th edition of JavaScript. So that's still new. The way to do it, this is another useful tool. If you go read up on this documentation sometimes, is, oh, how could I don't have access to this. What could I do? This is a bit of code, an ugly, ugly, ugly bit of code that does the equivalent of object.assign. So if you took all of this, for example, and put it into a program, now your object will have the object.assign method and you can use it if you didn't have it before. If you really want to start reading complex JavaScript code, you can read into that, but there's a lot you'll have to learn to really follow what's going on in all of that. That was a really good question too. Any others? All right. Well, I don't have a lot more because I really want to have you guys just sort of focus on methods, and we'll be introducing, let me look at my notes for my slides, some of the stuff that we'll be touching on in the next class. But I ended it with, last slide here is just, again, another review of a definition of an object. So if you're thinking of what an object is an entity that has properties and it encapsulates state and function in its properties. That's what an object is in JavaScript. That's generally a good description of what it is in most programming languages. Although a lot of times you will see the programming language say that properties are state and methods are something different. JavaScript treats everything as a property, whether it's a method or value. But that's really like the core definition of an object. Any questions? Any other questions I'm working with? Objects, this, methods? You can do them. Next time we will start getting into other ways to declare objects which aren't object literal syntax. Object literal is just by far the easiest way to do it in JavaScript. And I like it because it helps break some of the, if somebody's familiar with another programming language, it helps break their notion that you have to use new to create an object. JavaScript does support the new keyword, at least the new versions of JavaScript do, because they created the concept of classes, but it's not the same thing. It's all a lie. The cake is a lie. Yes, they do, but it's not the same way. So that's also something that we'll get into in some of the future classes. The question was, do they have inheritance in JavaScript? So if you're familiar with, you know, C#, Java, most object-oriented languages, your object or your class can inherit from another class, and that will help it inherit that behavior, or a class can implement interfaces. It depends on, and you know, Java, C#, it can implement a lot of interfaces. It can only inherit once. We'll get into it in a lot more detail. For the people who don't know what I was just saying, don't worry about it, but JavaScript doesn't have classes, so there's no class-based inheritance in that sense. JavaScript has objects and what's known as a prototype chain. So every object inherits from another object, and then it's just objects all the way down. So I can show you a little bit of a preview of some of that, show you sort of what I mean. I think I can. Let me see if this works. It may or may not work, because you don't really have access to this normally. Let's go with a different, somebody have a different model and manufacturer? Let's change it up. All right, it's a Nissan. What do they make? What? They make a Z360, right? Is that it? I can't remember. What is it? 370. All right. Wow, I can't spell. All right. All right, so we've got this car. The car actually has, let me see if this will work. You don't always have access to this stuff. Yeah, it's not defined. So let me see if it'll show this for me. It may not give me access to this. So this is saying like what the car actually inherited from is this other thing, and I can chain that and like keep going down. And because the car doesn't have anything more complex, it only has 2 layers of objects. This layer here is the base object, right? That's what that, and then that one has nothing in its chain. This is a little different than other object-oriented languages, so it's going to take a little bit of getting used to. I actually think, honestly, it's easier to understand if you've only ever done this than the classical version of object inheritance. But if you're familiar with classical object inheritance, this will probably be a challenge to really understand. And we may not get into all of the complex details of how this works, because it is confusing and complicated, and how it implements all the little bits underneath the covers. But you can, you know, I don't know, don't worry about this stuff. This is just me showing some future stuff. You can do some fun things with that. So if, for example, I want to create another object, and this is a very bare bones object, what am I going to have? It's very generic, vehicle, wheels for, I don't know. Engine, gas. So, oops, screwed something up. Oh, I didn't put a comma here. So I've created this vehicle. It's very generic. And I also have my car. It's a little more specific. Again, don't worry too much about these details, but I can set the prototype of my car to be a vehicle. And now if I tried like car.wheels, oh, car.wheels, it should, see? It's not gonna work that way. So let me try this. And this, it shouldn't even let me assign, so this should cause a problem. And now the car has like properties of this other object on it. And you can access those. Even if we look at the car, it doesn't explicitly have those. It's got a prototype with some of that stuff, but it's not explicitly on the car itself. It doesn't have those. I need to get rid of that prototype thing. Delete car.prototype. But the car should still, let me see here. Oh, that's the wheels, right? You don't actually see that on the car. It's sort of hidden, but it has access to that in the prototype chain. We'll get into all of that. Don't worry. That's really why I said objects are a complex thing that we're going to be covering for the rest of the class, because there's a lot going on with how objects inherit behavior, how you can compose things out of objects, etc. So that's more of a preview, or people who are familiar with other languages answering some of those questions, and also trying to show you that it's going to be confusing. Don't try and directly apply what you know. Any other questions on objects? That was good too. All right, I'm gonna take a quick glance at what I know will come up next that I didn't get to. So I know in the next class we'll talk about bracket notation. That's another way to reference properties on objects more dynamically. We'll talk about iterating over object properties. Once I've talked about that, one of your bits of work will be comparing objects to see if all of their properties are the same, practicing some of that. I'll give you some other syntactical sugar for like for each stuff. I'll talk about creating objects with the new keyword, and then we can dig into some stuff on some built-in objects. Let's make that. So I've got another bit of homework here. Let's pull some of that built-in object stuff out of just something that we preview. What I'd like is, I'll be putting something out on REPL, some more stuff today, but I also want to see people on the Slack channel choose one of these built-in objects and read some of the documentation on it. So go pull up documentation on a string or a number or a Boolean. You'll notice these are uppercased because the uppercase version is the object. So if you're seeing like string lowercase, you're probably seeing the primitive type. It could be object, it could be function, it could be array. Choose one of these built-in objects, go read on it, and then post something in Slack about a method on one of these objects that you learned about by reading on it. Oh, I learned about this method that's really handy, and give a quick summary of what it is. That way we're sort of learning how to read documentation, learning how to search that stuff up, and also sharing information that we've learned that might be helpful for everyone in class. Oh man, I learned arrays have a reverse method. Shouldn't tell you that yet because I'm probably going to have you reverse an array and I want you to do it by hand, but etc. But I want everyone to go do that and post in Slack and have conversations around that. If it's something you learn and you're going to be able to use it, respond, because we need to get that. You need to get used to looking that sort of information up and get comfortable reading this documentation. You spend a lot of time doing it when you program. You really do. It's no coincidence that my first tab, my pinned first tab, is a quick reference of all sorts of documentation. So. All right. If nobody has any other questions on this material, I think that'll be what we go over today. If anyone has any homework questions that they're still stuck on, I'm happy to hang out, answer any questions, help you work through any of that. Otherwise, enjoy the nice weather this weekend. At least what looks like it's going to be nice weather. Yeah, it was so nice yesterday. Oh my gosh, the end of the day. Beautiful. I'll see you guys later. Oh, I will be posting